Hello students, today we are going to discuss about a queue data structure. So this queue data structure is inspired from a real life queue which we observe every day in our day-to-day life. So this is a typical queue which you might have observed maybe at railway reservation counter, movie ticket booking counter, or maybe in the shopping mall or supermarket while paying the grocery bills. So you observe this queue. So this queue, if we observe carefully, right, there are two ends to this queue. This is the end from which people get the service and they get out of the queue. And this is another end where people join the queue, right? So these two ends, the end from where people join this queue is called as rear end. And the other end from where people get the service and they get out of the queue, that is called as front end. And the person who has entered in the queue first will be standing at the first, and the person who has entered the queue uh, at the last or very recently, so that person will be standing at the rear position. So the new person will come on the next position, that is whatever this rear is, rear plus one will be the next position for the next person, right? So the queue will grow like this. So this property where the person who has come in the queue first will get served first is called as FIFO property. FIFO, right? This is the property which is observed here in this queue, right? The person who is coming inside the queue first is getting served first. So this is called as FIFO, first in, first out, first in, first out, right? So there are three things here. If you observe, the first is this is the actual queue where the people are standing, and this variable which is keeping track of the person standing on the front position, and this is the variable which is keeping track of the person which is standing on the last position. Why these two are important? Because the next person will be coming at rear plus one position. The person who is entering will look at this rear variable or rear this rear position. The person who is getting served will be on the front position, right? For getting served and coming out of the queue, we'll be looking at the front, right? And the new person joins from the rear. That's why these two variables has the significance, or two ends has the significance, front end and the rear end, front, rear, and the actual queue. So we'll be implementing our queue exactly like this, where we'll have the actual storage or actual place where the people are standing, and this front variable which will keep track of the person who is standing in the queue at the front, or the person who will come out of from the queue from this front end, or will be deleted from the queue from this front end, and the new person will be coming to the queue from the rear position, right? Or the rear end, right? So that kind of data structure we want to build. So we'll be building an abstract data type, ADT, abstract data type. Abstract data type means it will be an object, right? And we'll be performing the various operations on that object by using functions, right? So our queue will look like this, right? As I said, there are three things. First is the actual storage. This is the actual queue, or in our case it is the storage for the data. Actual storage 0. We'll be using an array 1, 2, 3 and 4. Let us call this array as data array. Then the front variable which will keep track of the front element, and the rear variable which will keep track of the rear element. So front and rear are similar to this front end and rear end. And this complete structure or this complete object will be calling as queue, right? So queue will be using a structure data type, or a structure to use structure concept to build this object, right? We'll be using structure to create this abstract data type. This object is called as abstract data type. It's called as queue. This complete object including this data array, this front and rear is called as queue, right? Now on this queue we are going to perform various operations. The first operation is initialize operation, initialize. Second operation is we are going to check is the queue empty, queue empty operation. And the third operation is queue full. The fourth operation is enqueue, where we will insert elements inside this queue. And the fifth operation is dequeue. From by using this dequeue operation, we will be removing element from the queue. let's perform these operations one by one. So what is initialize operation? Initialize operation means as soon as we create this queue object, we will indicate that the queue is empty because we have just now created this object. There is no element inside this queue, so queue is empty. So how to indicate the queue is empty? By setting this front equal to -1 and rear equal to -1, because what front and rear stores? They stores the indices of the oldest element and latest element inside this queue. Oldest means oldest by time spent in the queue, right? And latest means the latest by time spent in the queue, oldest and youngest kind of thing. So this F and R store those indices, but as there is no element inside the queue, that means there is no oldest element or there is no latest element. So that's why we'll set this F equal to -1, R equal to -1, right? So this is initialize operation. As soon as the queue is created, setting F and R to -1, indicating that the queue is just now created, right? And it is empty. Right? This is initialize operation. I'm sorry, initialize operation. The second operation which will perform is queueempty on this queue, right? We'll be calling this queueempty function on this queue object to check whether the queue is empty or not. What is the indication that the queue is empty? Just now we have said if front equal to -1 or rear equal to -1, the queue is empty. We'll simply check here in this operation is front -1 or rear -1. If that is -1, then we'll say that the queue is empty. The second operation is queue full, right? When the queue will be full, when the element will be present on the last location. When the element will be present on the last location, we'll say that the queue is full. That means if R is equal to 4, in this case the last location is 4, we'll say that the queue is full. When the element is present on the last location, there is no more space, there is no fifth location here. No, we cannot insert more elements here, right? And when that will happen, while doing insertion, we look at R only, right? And if R is already 4, already last location, that means there is a person standing on the last location, there is no more space here, so we'll say that the queue is full when R is equal to last location. And the next operation is enqueue operation. Let us perform this enqueue operation in slightly more detail. So enqueue, right? So before performing enqueue operation, the first thing which we'll do is we'll call the full function to check if the queue is full, or we'll make sure that the queue is not full before performing enqueue operation, right? The first step before performing enqueue operation is queue full? That's the question we'll ask before performing enqueue operation. Let's say we want to perform enqueue or insert 10, 20 and 30 inside this queue. We want to enqueue 10, 20 and 30 inside this queue. The first thing is queue full, right? There are two answers to this. First is yes. How will I check it? If the queue is full, I'll simply look at value of R. If R equal to -1 or F equal to, I can check at F or R. If R equal to -1 or F equal to -1, I'll say that the queue, the queue is full means I'll simply check only I was talking about empty. So if in order to check if the queue is full, I will look only at R, and if R equal to last location, that means I will conclude the queue is full. If R equal to last location in this case is 4, right? Last location in this case is 4. So I'll conclude queue is full. If queue is full, I'll say that overflow. Overflow means the queue is full, we cannot insert. The other answer is no, the queue is not full, right? The queue is not full. In that case, there are again two possibilities when the queue can be not full. The first is the queue is empty. The queue is empty, right? The queue is empty. If the queue is not full, there are two choices or the two options. The first is the queue is empty like this, and the second option is there are some elements inside the queue, but the queue is not full, right? There are some elements are present inside the queue, right? So these two situations will be there. After making sure that the queue is not full, right, there are two situations. First is queue is empty, there is nothing inside the queue. The other is there are few elements, that means the first few positions may be occupied and these two may be empty, right? So that is there are some elements. Now let's try to insert this 10 by using this flow chart kind of, or this procedure. The first question I'll ask is queue full? I'll check R. R is not 4. R is not 4. I'll ask a question here. Is R 4 here, right? R is not 4 here. I'll ask this question. Is R 4? Is R 4? Right? That question I'm asking. And I'm getting the answer R is not 4. Then yes, I'm getting the answer R is 4. R is 4. Right? So I'll say that the queue is full. Here R is not 4. R is not 4, right? That's why the queue is not full. Here R is 4. Okay, so now in this case we are getting this answer, queue is not full. Now the second question I ask is, because now I am going to perform NQ operation, right? I am going to perform NQ operation. While performing NQ operation, there are two situations. The first is the queue might be empty and there might be some elements. So I'll ask, is the queue empty? Right? Is the queue empty? How will I check whether the queue is empty or not? I'll check the value of either F and R, F equal to -1 or R equal to -1, right? F equal to -1 or R equal to -1. If that is the situation, that means this is going to be the first NQ operation or first insertion, right? This is going to be the first NQ operation or first insertion. So if this is the first NQ, if this is the first NQ, the element will be inserted on the very first location of this array. What is the first location of this array? 0, right? That means the element will be inserted on 0th location, and that is the first element and the last element. That means F is 0 and R is also 0, because the element which I just inserted is the first element as well as it is the last element. Latest and oldest is the same. That's why when this is the first NQ operation, I'll set F equal to 0, R equal to 0, and go to data array. Inside data array, on R location, I'll insert this 10, right? So this will occur, or this will happen when the queue is empty or when this is the first NQ operation, right? So in our case now, in order to insert 10, we'll set F equal to 0 and R equal to 0, and we'll go to data array on R location and insert. What is R? R is 0, so data of 0 will be 10, right? Let's perform subsequent insertions. So 20. The first question is queue full? How will I check that? Is R equal to 4? No, R is not 4. The queue is not full. I'll come here. That means I can perform NQ operations. Now before performing NQ, I'll check, is this the first insertion or is it the normal insertion, right? So first insertion means is the queue empty? So I'll check, is F -1 or R -1? No, they are not -1. So I'll that means this is not the first insertion. I'll go to this choice where this is a normal insertion. If this is a normal insertion, as we saw in the case of queue, the insertion happens from the rear end. The insertion happens from the rear end. I look only at the rear end, right? So whatever rear is, right? The rear is 0 means the element is present on 0th element. The next element should come on rear plus 1 position, that is 1 in this case. So if this is a normal insertion, I look only at rear variable and increment it by 1, right? So in this case R was 0, 0 plus 1 is 1, right? And then go to data array on rear location and insert 20 there. So data of R is 1, so data of 1 is 20, right? So 20 inserted, 10 inserted. To insert 30, right? The first question is queue full. Check at, look at R is not 4, the queue is not full. I will come here. Is the queue empty? R is not -1, so the queue is not empty. So that means it's a normal insertion. If it is normal insertion, increment R by 1. R equal to, R was 1, 1 plus 1 is 2. R was 1 for inserting 20. Now R is 2, R is 2. So go to data of R, that is data of 2, and insert 30 there. So 30 will be inserted here, right? So let's perform the few more NQ operations, 40, 50 and 60, right? 40, 50 and 60, right? So the insert, to insert 40, the first question, is the queue full? No, queue is not full. R is not 4. So is the queue empty? Right? The queue is not empty, right? So we are checking this, we are going here only when we are getting the answer that the queue is not full. That means there is we can perform NQ operation, right? If the queue is full, right, we'll simply print overflow. For 40, the queue, for inserting 40, we found that the queue is not full, right? Then the second question which asks is the queue empty? If the queue is empty, that means this is the first insertion. In that case, we have to follow this procedure. If the queue is not empty, we have to follow this process where we simply increment R by 1. R was 2, 2 plus 1 is 3. So then we'll go to data of 3 and insert 40 there. Data of 3 means in the data array, third location. Right, to insert 50, we check again this queue is not full, this is not empty, queue is not empty. Then this is a normal insertion where we'll increment R by 1, right? So R was 3, R becomes 4, right? So R becomes 4, and we go to data array on the fourth location and insert 50 there, right? So 50 inserted. To insert 60, right? To insert 60, what we do, again the same process. First question, is the queue full? If the queue is, we get the answer that this time that we want to insert 60. We want to insert 60. Let me take different color here. Right? So we want to insert 60. Right? What is R? R is 4. Right? So we are asking question, is queue full? What we check? We check the value of R. R is 4 and last location is also 4. Right? That means R is 4. That means the element is present on the last location. That means there is no more space inside this queue, and we conclude that the queue is full, and we'll print overflow and we'll quit this, right? So this is the queue, this is the NQ operation which we saw, right? Very simple algorithm. First question which you need to ask is the queue full? If the queue is not full, then we can perform NQ operation. And while performing NQ, there are two situations. The first is, this is going to be the first insertion or the first NQ operation. The second situation is, this is the normal insertion where there are already few elements inside the queue, and we are going to insert this element on the next location next to that means R plus 1 location, right? We'll simply increment R by 1 and insert on that location. Here we'll set F and R both to 0 and we'll insert on 0th location, right? So that is NQ operation. We'll see one more example of NQ in the next video, and then we'll start the DQ operation. So stay tuned. Thank you for watching.